Okay. Let's review the substitution, solving systems of equations by substitution. We're going to do a little bit different one today. It's easier to do, but it's harder to understand. Once you do a few of them, you're going to find that that's a method that you'll prefer to do, I think. So if we have this, if we have 3x plus 4y equals 12, and 3x equals 12, system of equations. Now what we want to do is we want to solve one of these equations or the other, excuse me, for one of the variables, one of the letters. The easiest one to do is the bottom one. 3x equals 12. We divide it by 3, and we get x is 4. Now we can plug it into the other equation, not back into this one, because all you'll get is 12 equals 12, and that doesn't help us any. Now we want to find out what is the value of y. So we take 3x plus 4y equals 12, but instead of x, we're going to substitute, ergo the name substitution. We're going to substitute the 4 in here for x. So we have 3 times 4 plus 4y equals 12. 3 times 4 is 12, plus 4y equals 12. Now we want to solve this for y. So we're going to subtract 12 from each side. Excuse me. Subtract 12 from each side. We get 4y equals 0. Divide by 4, y is 0. Divided by 4 is 0. So our answer here is, remember, they're always in the form xy. So it's 4, comma, 0. That's where the two lines cross. Okay, that's substitution. You can see the number of steps involved here is kind of long, but it's really pretty easy to do. It's just simple algebra. Let me do another one, just for fun. If we have this.
You moved the paper.
Oh, I'm sorry. You still need that?
Yeah, I just got one thing right.
Sorry.
That's okay.
I wish I could say I'm gonna do better, but I probably won't.
Got it. Thank you.
Okay, sorry. Okay, let's do another one. Let's a little bit. Should have done this one in the first place. 3x plus 2y equals 27, and x equals y plus 4. System of equations. Now again, we're going to substitute. Remember, x and excuse me, and y plus 4 are the same. They're equal. They're exactly the same. Just like a tire from Discount Tire and one from NTB. They're the same. So what we're going to do is we're going to take 3x plus 2y equals 27. But instead of x here, we're going to plug in y plus 4. So we have 3 times y plus 4 plus 2y equals 27. And remember, the reason that we're doing this is you cannot solve an equation that has 2 or more variables in it. So we need to get rid of one of the variables. And this is how we do it. Now we have distributive property here. So we have 3y plus 12 plus 2y equals 27. Everybody with me here? Okay. Now we combine like terms. 3y and 2y is 5y plus 12. Don't forget the plus 12 equals 27. Subtract 12 from each side. And we get 5y equals 15. This is a y here. Divide by 5. Y is 3. At this point, take you a slug of Diet Coke. Ah, that's a good Diet Coke. Now we know what y is. Now we have to figure out what x is. It doesn't make any difference which equation you put it into, but let's be lazy. Take the easy one. This equation here, x equals y plus 4, it's already solved for x. X is already over here by its own self. So now we plug 3 in for y. X equals y plus 4. X equals, y is 3. So x is 7. So the solution is 7 comma 3. That's where the two lines will cross at 7, 3. Everybody got it? I have a nice pretty quiz on the D2 and L. How about if we go over it together? Would y'all mind terribly if we did that?
Which quiz?
I think it's number 7. But to tell you the truth, I don't remember. Wait a minute, I'll go look. Just a second. I have a sheet in there that tells me what, how, what, where, when, and why.
Yep, it's quiz 7.
Oh. Okay, yeah, it is quiz number 7. Okay. 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 And we'll go over that when we get finished with this other misery. Okay. 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 And next, what's today? Thursday? Yeah, I knew that. Next Tuesday, we're going to review for test number 2. So, and I'm going to go over every problem with you just like we did before. So we shall do that on Tuesday. And unless I'm too hungover, we'll go over that go over the test on Tuesday. Now, what we're going to do now, there's 3 ways of solving systems of equations. Graphing, we did Tuesday, last Thursday. Substitution, we did day before yesterday. And the third one is elimination. AQ. systems of equations by elimination, E-L-I. Now what we're going to do here is we're going to eliminate one of the variables. Now, how in the world do we do that? This is about as easy as they get right here. If we have x plus y equals 5 and x minus y equals 3, system of equations. Now what we want to do is we want to add these two together. U-A-T-I-O-N-S. Add the two equations together. And when we do, we want to eliminate one of the variables. Okay, now this one is already set up for us. If we have y minus y, what does that equal? 0. It's eliminated. Excuse me. We're going to add these two equations together. And we get x plus x is 2x. Y minus y is 0. It's gone. It's eliminated. Equals 8. Divided by 2. X is 4. Now the elimination method you can see is much easier than the substitution method, but it takes a little more thinking about what's going on. Now we're going to substitute. We know that x is 4. We're going to substitute it back into either equation. It doesn't make any difference. Let's take the top one because all the numbers are positive. So we have x plus y equals 5. We plug, and we know that x is 4. 4 plus y equals 5. Subtract 4 from each side. Am I going too fast? Subtract 4 from each side. Get y is, see, 5 minus 4. Carry the 730. That's September. Yeah, 1. So our solution here is 4, 1. Okay, it's very, very easy, but it's. I remember one time I was showing this method to a class, and there was a girl in there super smart, reminded me a lot of myself. Yeah, okay, super smart, and she said she looked at this and she said, "Boy, that doesn't make any sense at all. You're going to have to explain that better." So, yeah. So tell me if it doesn't make much sense. Now, the one thing we want to remember is if we have x plus y equals 8, and we multiply everything by 4. And this doesn't have anything to do with this problem up here. All I'm telling you is if we multiply this equation by 4, we get 4x plus 4y equals 32, right? This equation and this equation are the same. They just look different. It's just like 1/2 equals 5/10. These are the same. Same thing happened here. So what we're going to want to do, they're not always going to be this simple. We're going to have some equations that we're going to have to change in order to get rid of one of the variables. Now let's do another one that's again very easy. X minus y equals -2, and x plus y equals 10. Now you can see we have the y's are opposite from each other, and that's what we want, because when we add these together, when we add these two equations together, it eliminates the y's. So we have 2x, y minus y is 0, it's eliminated, equals 8. Divide by 2, x is 4. Now we plugged x is 4 into either equation. It doesn't make any difference because remember, in systems of equations, the solution has to work for both of the equations, not just one. So let's use the bottom one because they're all positive numbers. Okay, x is 4. And again, we subtract 4 from each side. Y is 6. So our solution here is 4, 6. Mm-hmm. Okay. Mm-hmm. Mm-hmm. Well, that one doesn't look like any fun. Okay. Okay. Now, the one thing you have to do here before you do any of this other misery is you have to put the equation, U-A-T-I-O, put the equations in standard, A-N-D-A-R-D, standard form. Now, standard form is AX plus BY equals C. In other words, you want the constant over here by itself, and all the X's and the Y's over here on the other side. So the first thing you want to do is to put these in standard form. But we don't use standard form a lot because it doesn't tell us very much. Like slope intercept tells us the slope, and the y-intercept, we don't use that a lot. But we do use well, this book has some lousy examples. Golly. Let's see if the other one's any better.
Is that AX plus BY equals C?
Yes.
Okay.
Okay, just like if we had 3x plus 2y equals 7, this is standard form. What we did here is, in order to get it this way, you want to solve the equation for the constant, for the number. The number's over here by itself, that equals all this misery over here.
Right.
Standard form. And that's the first thing you want to do when you're solving by elimination is put it in standard form. Let me see, that substitution, elimination. No, that one's not any better. Oh, man.
Oh, that's 12Y. Is that 12Y, 3X, and 12Y? Or 3X plus 2Y?
3x plus 2y.
Okay, all right.
AX plus BY equals C.
Right.
Let me see if I can find a decent example here. 3y, 2y, no, that one's stupid. Boy, oh boy, these books are horrible. Mm-hmm. 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 Man, oh man, oh man. Okay, here we go. 3x plus 2. I'm going to change this one around. Everybody have this?
Yeah.
Okay. Boy, it's Thursday night, right?
Right.
Ooh, date night. And she's good looking, too. Mm-hmm. Now I've lost my place. 3x plus 2y. Let's see if this will work. 3x plus 2y equals 0. And 3x. Oh, stupid. This is even more stupid than the other one. Minus y. Well, we'll do it. Minus y equals 3. System of equations. Now, do we have to change either one of these things? No, because we have one variable is the opposite of the other one. In other words, when we add these two equations together, excuse me, it's going to eliminate the x's. 3x minus 3x is 0. Now we're going to add, again, we're going to add these two equations together. 3x minus 3x is 0. 2y minus 1y is just y equals 3. Right? Okay. Now we plug this back into, let's plug it into the top one. It looks easier. 3x plus 2 times y is 3, equals 0. So 3x plus 6 equals 0. Right? 2 times 3. Subtract 6 from each side with a real simple algebra problem. 3x equals negative 6. Divide by 3. X is negative 2. So our solution here is negative 2 comma 3. And how would we double check to make sure we're right? Plug it back into both equations and see if they equal each other. What's that one? That one's stupid. That one's equally stupid. That one's stupid. Okay, here we go. Here's a good one. 2x minus y equals 12. And we have 3x plus 2y equals negative 3. System of equations. Now look, when we add these together, it doesn't eliminate either of the variables. So what are we going to have to do? We either have to multiply or divide. Multiply or divide. One equation, sometimes we have to do both equations. One or the other, where we have the opposite of. Can we multiply 2 times anything? Any whole number?
Yeah.
To get to negative 3? Because what we want is negative, no. How about negative y plus 2y? We can multiply this equation by 2. And we get 4x minus 2y. Okay, now we have 2y minus 2y. And that's going to eliminate equals 24. Okay, now remember, this equation and this equation are the same. We just changed them a little bit. We didn't change the value of it any, we just changed the look of it. Now we're going to add these two together. 3x and 4x is 7x. 2y minus 2y is 0. 24 minus 3 is 21. Divide by 7, x is 3. Okay, now let's plug this one into, let's use the second equation because everything on this side of the equation is positive. So let's take 3x plus 2y equals negative 3. But instead of x, we're going to put in 3. 3 times 3 plus 2y equals negative 3. 3 times 3 is 9. Plus 2y equals negative. Come on, stupid. 3. I think I'm having a stroke here. Now, again, we have a real simple algebra problem. Let's subtract 9 from each side. 2y equals negative 12. Divide by 2. Y is negative 6. So our solution here is 3 comma negative 6. Now again, the thing that we want to do here is eliminate, excuse me, we want to eliminate one of the variables. When we add the two equations together, excuse me, when we add the two equations together, we want to eliminate one of the variables. Well, you can see as it is here, we didn't have the opposite of either one of these variables. So what did we do? We multiplied the top one by 2, and then we got negative 2y. That would eliminate that one when we added them together. Let's see. X plus y equals 3. Negative 3x. Plus 2y equals negative 19. System of equations. Now, what can we multiply or divide? One of these equations or the other. And like I said, sometimes you have to do both equations. But this one we can do, what can we do? We can multiply the top one by 3, and that would give us 3x, and that's the opposite of negative 3x. And that's what we want. We want the opposite. Or we can multiply the top one by negative 2, and we get negative 2y plus 2y. Why don't we do this one by 3? And we'll get 3x plus 3y equals 9. Multiply everything in here by 3. And again, that, well, my handwriting is getting worse. Now that didn't change the value of this thing, it just changed the look of it. Just like 1/2 and 5/10 is the same, they just look different. Now we're going to add these two together. Let's remember this one and this one are the same, they just look different. 3x minus 3x is 0, that one's gone. 2y and 3y is 5y equals negative 19 plus 9 is a negative 10. Divided by 5, y is negative 2. Okay. Now let's plug our negative 2 any one of these three equations. Remember, this one's the same as this one, just looks different. But let's use this first original equation. If we have x plus y equals 3, and we know that y is -2, and y minus 2 equals 3, we're going to substitute -2 in for y, add 2 to each side, x is 5. So our solution here is 5, comma, -2. Right?
Hold on. You move your paper up. Can you move your paper back down?
Oh, sorry.
Thank you.
Sorry, I'll do better.
That +2, is that 12?
Where?
Up, right, come down. Right there.
We're adding 2 to each side. We're trying to, what we have here is x minus 2 equals 3, right? This is this.
Right.
Now, how do we solve this for x? Add 2 to each side.
Oh, okay, I got you now.
X is
Okay.
5.
Okay.
Mm-hmm. Mm-hmm. Everybody got it?
Got it.
Okay. Mm-hmm. Well. Okay, now what if we have this one? 2x minus y equals 12. 3x plus 2y equals -3. System of equations. Now, can we multiply 2 times anything to give us 3? No. How about -y and 2y? Now again, what we want is to eliminate one of the variables. So can we multiply? We multiply or divide. We're going to multiply this one by 2. And when we do, we're going to get -2y. -2y plus 2y is 0. That way we're going to eliminate the y. So we multiply everything in here by 2. We get 4x minus 2y equals 24. And remember, this equation and this one are the same. They just look different. Okay, now we have one of the variables is the opposite of the other. 2y minus 2y is 0, and that's what we want. We want to eliminate one of the variables when we add these two equations together. 3x and 4x is 7x. 2y minus 2y is 0 equals 21. 24 minus 3 is 21. Divide by 7, x is 3. Now, let's plug it into, now remember, at this point, you can use either equation you want, doesn't make any difference. Let's use this one because all the numbers are positive. So we have 3x plus 2y equals -3. This is this. We do 3 times 3. Now we plug in 3 for x plus 2y equals -3. 9 plus 2y equals -3. Subtract 9 from each side. 2y equals -12. Divide by 2. Y is -6. So our solution here is, remember, they're always in the form xy. So it's 3 comma -6. Okay. Again, the important part of this question is figuring out which one of these equations, and like I said, sometimes you have to do both equations, but is to get one variable, one of the letters, opposite of the one in the other equation. Okay. Let's see. Everybody caught up?
Yep.
Okay. How about this one?
Are you going over what you went over last time?
I did that at the beginning of class.
Okay, I'm really sorry. I don't know if you got my email.
You did what?
I said, I'm really sorry for being late. I had to try to download it on my phone.
You can just drag yourself down to the principal's office and explain it to her.
Okay.
So that's okay. At the end of class, I'm going to go over the quiz that you have for next Tuesday, and it has some of those problems on it. There's a couple of them on there, I think. X plus y equals 3, -3x plus 2y equals negative. Didn't I just do this problem?
Yep. Yep.
I sure did. Stupid boy. Okay, let's do it again. System of equations. Now, what do we want to do? We want to get the opposite of -3x, which is +3x, or we want -2y. So we can multiply this by either 3 or -2. So let's do it by 3. It'll be more easier. Okay, we multiply everything here by 3, and we get 3x plus 3y equals 9. And again, this equation and this are the same. They just look different. Now we add these two equations together, and we're going to eliminate this variable here. 3x minus 3x is 0. It's gone. It's eliminated. 2y and 3y is 5y equals -10. Divide by 5. Y is -2. Now let's plug it into this equation because the numbers are easier. X plus y. Who was it that said that? Ms. Gorham, was that you? That boy's just lazy and stupid. I heard that. Rotten old thing. Okay, x plus y is 3. That's this equation right here. Now, instead of y, here we're going to plug in -2. So we have x minus 2 equals 3. Very simple algebra. Stupid boy. Add 2 to each side. So x is 5. So now the solution to this system of equations is 5 comma negative 2. And at that point, let's drink. Let's see what else we have. Okay. Okay, here's a good one. Everybody got this one okay? Okay, here we go. Stand back. Two x minus 8y equals 0, and 4x plus 5y also equals 0. System of equations. Now, is 2 a factor of 4? Yes. So we might be able to do something to this, to the 2 to get it to negative 4. And 5 and 8, neither one is a factor of the other one, so let's not fool with that one, unless you want to. Okay. What do we want to multiply this top one by to be the opposite of 4x? We're going to multiply by negative 2. As negative 2 times 2 is negative 4x plus 16y equals 0. Okay, we multiply everything in here by negative 2. Because what do we ultimately want? We want to eliminate one of the variables. And this was the easiest one to do. 4x minus 4x is 0. 5y plus 16y is, what was that, 21? 21y equals 0. Divide by 21, so y is 0. Now we plug it back into either equation. It doesn't make any difference. Let's do this one. 4x plus 5y equals 0. Instead of y, we're going to plug in 0. So 4x plus 5 times 0 equals 0. 5 times 0 is 0. So we end up with 4x equals 0. Divide by 4, x is 0. So our answer here is 0, 0.
Could you pull your paper down a little bit, Professor? I want, okay. So that was 4x times 5 times 0 equals 0. Okay.
I'm sorry, say that again.
The third line, the second line, I couldn't see it. I got you now.
Oh, okay, I'm sorry.
That's okay.
On my screen, I'm real small. I can't really, that's the best excuse I have anyway.
Got it.
Everybody got it? Okay, now here's one. This is as difficult as these problems get. If we have 2x plus 3y equals 21, and we have 5x minus 2y equals negative 14. Now, what can we multiply or divide by 2 to get it to 5, or negative 5? Nothing, no, good Lord. There are no whole numbers. We can multiply by 2.5, but who wants to do that? But is 2 a factor of 3? No. So what we're going to have to do is we're going to have to multiply something times both equations to get it to eliminate one of the variables. Now look, 2 and 3 are the smaller numbers, plus the fact this one's already negative and that one's already positive. So let's multiply this one by 2 and this one by 3. Plus 2 times 3 is 6, and 3 times negative 2 is negative 6. So that'll get us what we want. We multiply the top one by everything by 2, and we get 4x plus 6y equals 42, I think. And we multiply the bottom equation by 3, we get 15x minus 6y, and that's what we want. We want to be able to, when we add these two together, we want to be able to eliminate one of the variables. Equals a negative, is that 42? It's not that I don't trust myself, it's just that I don't trust myself. Yes. Oh, the boy's smart. Okay, now we want to add these two together. And when we do, we're going to eliminate the y variable. So 4x and 15x is 19x. That's gone. Equals 0. 42 minus 42 is 0. Divide by 19. X is 0. Let's use this top equation. Again, it doesn't make any difference which one you use. Get the easiest one. So if we have 2x plus 3y equals 21, we plug 0 in for x. So 2 times 0 plus 3y equals 21. 2 times 0 is 0, so we end up with 3y equals 21. Divide by 3, y is 7. So our solution is 0, 7. Okay, and again, this is about as difficult as these get, and it's really not all that difficult. What we want to do is we could have multiplied this top one by, what, -5 and this one by 2, and would have eliminated these two. But these numbers are a little smaller and easier to deal with. Okay. Okay. Once you do a few of these, they're really not difficult, they're just different. Okay, y'all ready to go over the quiz? You know, I did the same thing with the Math 310 group last night. And I told them, I said, you know, I'm going over, I'm giving you the answers. But yet there's going to be 2 or 3 of you that won't get 100. Well, I was wrong. There were 4 of them that didn't get 100. It's not funny. Okay. Okay, this is quiz number 7. QIZ. And it's due next Tuesday, I think. Okay, number 1. Solve by substitution. S-T-I-T-U-T-I-O. Now what we've just been doing with all this other misery here, remember this one's elimination. You'll see some of the books will call this by the addition method, where you add the two together. I've always seen it by elimination, but you know, who knows what they do. Solve by substitution. If you have x plus y equals 12 and y equals 3x. Okay, so we know that y and 3x are the same. So we're going to substitute the 3x in the other equation for y. So we have x plus 3x, because y is 3x, equals 12. When we combine like terms, so 4x equals 12, divide by 4, x is 3. Now look, this one's already solved for y. Y equals 3x. So now we just substitute the 3 in for x. Y is 3 times 3, so y is 9. So our solution here is 3, 9. And that's the answer. Everybody got it?
Wait just a moment. Wait just a moment. Wait. Got it.
Okay, number 2. Ms. Gorham, this is what we did at the beginning of class. Solve by substitution. We reviewed S-T-I-T-U-T-I-O. Solve by substitution. If we have 3x plus 5y, 26, and y equals 2x. System of equations. Basically the same problem that we had before there, just a little bit longer. So remember, y and 2x are the same, so we're going to substitute 2x in for y in the other equation. 3x plus 5 times y, but instead of y we plug in 2x, equals 26. Now we distribute the 5 over everything inside here. We get 3x plus 10x equals 26. Is that right? My brain just went numb. Yeah. We add these two together. 13x is 26. Divide by 13, x is 2. Now again, this one's already solved for y. So let's use this one. Y is 2 times x. So y is 2 times 2. 2 times 2 is 22. So our solution is 2, 4. Can you see how much easier the elimination method is than this misery? Number 3. T-I-T-U-T-I. Solve by substitution. Where are we? Number 3. 2x plus 5y equals 7. And x equals -1 minus y. Okay, x and -1 minus y are the same. So we're going to plug this into the first equation. But instead of x, we're going to plug in -1 minus y plus 5y equals 7. Now we distribute the 2 over all this misery in here. We get -2 minus 2y plus 5y equals 7. Combine like terms. So we get -2. -2y plus 5y is a positive 3y equals 7. First, we get rid of addition subtraction. So we add 2 to each side. 3y equals 9. Divide by 3. Y is 3. Please be sure and tell me if I'm going too fast.
You moving. You moving.
You all right?
Yeah, you moving.
Okay. Okay, now y is 3. Now we want to know what x is. And you can plug it into this one if you want. Looks like a whole lot of trouble though. This one's already solved for x. X equals -1 minus y. So we have x equals -1 minus, but instead of y, we're going to plug in 3. So x is -4. -1 minus 3 is -4, I think. So our solution is -4 comma 3. And if you wanted to, you could plug it back into the original equation. -4 into either one, doesn't make any difference. 2 times -4 is -8 plus 15. -8 plus 15 is 7, so we're right. And if you did the other one, it would be the same. Everybody got it? Am I going too fast?
Yeah, all right.
You all right? Number 4. Solve the system of equations by substitution. substitutio. X equals, whoa, number 4. X equals 5 minus 2y and 2x plus 4y equals 6. Okay, this one's already solved for x, so we really don't have to do a whole lot here. We're gonna substitute this. X is this, so we're gonna plug that into here. So 2 times 5 minus 2y, that's a y, plus 4y equals 6. Now we do distributive property here. 10 minus 4y plus 4y equals 6. Combine like terms. -4y plus 4y is 0. It's eliminated. Does 10 equal 6? No. So our solution here is the null set. Null set means that there are no solutions. I don't remember whether I did that in this class or not, but somebody used this for 0. do not use this for 0. Back in the day when I was a little kid, computers were, or printers actually, were not what they are today, and they had to distinguish a 0 from the letter O, and this is how we did it, or how they did it. But this means something else. This means that there are no solutions. So the answer to number 4 is the null set. Let's call it N-U-L-L, null set. Number 5. Good Lord, how many of these substitutions? Solve by substitution, number 5. Okay. Why did I put it with this same boneheaded problem in here? Okay, x and y minus 3 are the same, so we're going to plug this into the other equation. So we have 4 times x, but instead of x, we have 4y minus 3 plus 3y equals negative 5. Now we do distributive property here. Excuse me. We multiply 4 times everything inside here. We get 4y minus 12, right, plus 3y equals negative 5. Then you scratch your left shoulder. So I got some itchy scratches going on here. Combine like terms. 4y and 3y was at 7. 7y minus 12 equals negative 5. Okay, now we get rid of addition subtraction first. Plus 12 plus 12. 7y equals 7, huh? Divide by 7. Y is 1. Okay. Now again, this equation right here is already solved for x. So let's use this one. X equals y minus 3. So x equals, instead of y, we plug in 1 minus 3. So our x is negative 2. So our solution, can't even draw a circle anymore. So our solution is
Can you raise it up? Can you raise your paper up? Thank you.
sorry, negative 2 and 1. Now, can you see how much simpler elimination is than all this misery here? Very easy.
Yep.
But it's a little bit more difficult to understand, or it is at first. And I'm telling you, at some point, you're going to prefer to do elimination. You'll realize we're almost 40, I think a little over 40% finished with this semester. Y'all believe that? You believe it. Y'all got this?
Got it.
Okay. Was that number 5?
Yeah, we're on number 6.
Number 6. Solve by elimination. E-L-I-M-I. I'll give you a little secret here. You can really use either substitution or elimination. Either one, it doesn't make any difference. But I'd like to see you do this. So if we have x plus y equals 5 and number 6 and x minus y equals 3. System of equations. Now look, we don't have to do anything here because we have y and minus y. One is the opposite of the other. So we don't have to change, excuse me, we don't have to change either one of these. All we have to do is add these two together. We get 2x, y minus y 0 equals 8. Divide by 2, x is 4. Let's plug it into the top one because everything's positive here. Okay, so if we have x plus y equals 5, instead of x, we're going to plug in 4 plus y equals 5. Oh, stupid. Subtract 4 from each side. Y equals 1. So our solution here is 4, 1. Now, what do you like doing better? This way or this way? Yep, me too. Number 7.
Very good.
I'm sorry? I couldn't hear you.
Gotcha.
Solve by E-L-I-N-A-T-I-O-N. Solve by elimination. We have x minus y, 2x minus y equals 12. Is that right? And 3x plus 2y equals -3. Let me make sure I got that perfectly in there. 2x minus y equals 12. 3x plus 2y is -3. That's right. Well, okay. Now remember, what we want to do is add these two equations together and eliminate, ergo the name elimination, and eliminate one of the variables. Now, if we add these things together here, the x's are going to be 5x. That doesn't eliminate anything. Minus y plus 2y. This one's negative and this one's positive. So all we want to do is multiply this one by 2. And that'll give us -2y. And the other one's plus 2y. That'll eliminate that one. So we get 4x minus 2y equals 24. I'm sorry?
Okay, I got you.
Everybody get the idea here? Because I don't think I explained that real well. What we want to do is when we add these two equations together, we're going to eliminate one of the variables. Now, what can you multiply one equation or the other? So one of the variables is the opposite of the other equation. Okay, so if we multiply the top one by 2, we're going to get -2y. So now we're going to add these two together. Remember, this equation and this one are the same, they just look different. 3x and 4x is 7x. 2y minus 2y is gone, it's eliminated. Equals 21. -3 plus 24 is 21. Divided by 7, x is 3. Now, let's plug it into the, doesn't make any difference. Let's plug it into the bottom one. 3x plus 2y equals negative 3. So instead of x, we're going to plug in 3 plus 2y equals negative 3. 9 plus 2y equals negative 3. Subtract 9 from each side. 2y equals negative 12. Divide by 2. Y is negative 6. So our solution here is 3 comma negative 6. That is the solution. That's where the two lines cross. Get you a drink of Diet Coke, and that'll do it. Any questions? Some of this misery is going away, but you're going to see some of it in 310 and college algebra. It's the same stupid stuff. Everybody got it?
Got it.
Got it. Thank you.
You're welcome. Y'all have a good weekend. Stand up, put your chairs in.
Bye.
Bye-bye. Take care.
Have a good one.
Stop.
Have a